Hey guys, we're going to do a quick example of this overbooking problem. So the situation is that we have an airplane that has 12 seats. However, we sold 15 tickets, so there's a chance we might overbook the flight. So the idea is that 9 customers have already shown up, and based on that, we know that the remaining passengers each have a probability of 0.45 of showing up. So we want to figure out, based on that, what's the probability that the flight is going to be overbooked. So if you think about this problem, if the flight is going to be overbooked, that means that we need to think about what is the probability that more than 3 more customers show up, because we already have 9 customers who have come on. So as long as we get up to 12, the flight won't be overbooked. But if we get past 12, we are going to have an overbooking. So there's 3 more customers who could possibly show up. If we get to that fourth passenger, then that means that we're going to be overbooked. So when we're looking at the probability for the flight being overbooked, we're really looking at what's the probability that of the remaining 6 customers, what's the probability that 4 or more of them show up. So I'm looking at what's the probability of 4 or greater customers showing up. Now this is out of 6 remaining customers. Okay, so out of those 6 remaining, what's the probability that 4, 5, or 6 show up? So we could do this with our calculators pretty quick. Remember that the calculator only does up to a certain amount. So if we want to do this with our binomial cumulative distribution, what we could do is 1 minus the probability that 3 or fewer show up out of the 6, and then that should give us our probability. So we're going to pull up the calculator, and I'm going to go to my distribution. I'm going to look down to the binomial cumulative distribution. So in this case, there are 6 total passengers. There's a probability of 0.45 for each one of those showing up, and I want there to be 3 or fewer showing up. So I'm going to find that probability. So that's this probability here. This is the probability that we will not overbook. That would be if only 3 passengers show up. So if I want to find the probability that we will overbook, it's just going to be the complement of that. So it should be approximately 0.255. That should be the probability that I do overbook. So again, we can't actually do this probability in the calculator, but we can do the complement of it, which is this part right here, doing our binomial cumulative distribution. So the last part of this is, what is the probability that the flight has empty seats? Well, in order for the flight to have empty seats, then I need no more than 2 people to show up, because if 3 people show up, then the flight will be full. But if I have exactly 2 or fewer show up, so x is less than or equal to 2, then that should mean that there's at least 1 seat left on the plane. So again, I can go over to my calculator. In this case, I'm doing a less than or equal to 2, so I can just use my binomial cumulative function or distribution. So again, I go down to the cumulative distribution, and I'm going to do out of the 6 passengers, there's a 45% chance that each will show up, and I want 2 or fewer to show up. So this probability should be about 0.441 or 0.442. All right, so I hope that gives you a nice little example, and you can use this to solve your particular problem with your particular numbers.